Hello, everyone. Welcome to the December 2013 Professor Messer Network Plus Study Group. We have brought all of you together from around the world to ask me questions about the Network Plus certification. The real question would be, can he actually answer them? We'll find out over the next hour. And I've spent all of this time through the last month taking your messages, your calls, your emails. When you've registered for this, it's something where you send me a question during the registration process, and then I put them all together and try to pick out things that might make sense for us to talk about this month. We, of course, do this every month, so feel free to go around and see the past versions of the study group that we've done. One of the things that I do is keep an archive, although I don't have last month's archive in my list on the website. I do have it posted, and everything is at YouTube, and it's on the Professor Messer website, so you really can't go wrong. As I mentioned, I do these every month, so you can always come join us live when we do them. I do post that on professormesser.com/calendar, and for those of you that are live, I watch the chat room, and I take your call. So you'll notice on professormesser.com/live that I do have phone numbers there that you can call in, and I'll be able to take those calls and those questions live as we do that. Of course, I do have our live Network Plus videos. Every single minute of every single video is available to watch free on the Professor Messer website. You can find all of that on the Professor Messer website. But if you'd like to have one for offline use, for when you're not connected to the internet, I can't imagine when that would be, but supposedly some of you are not connected to the internet at times. I start scratching. It starts bothering me when I do that. But if that's a problem for you, you can always purchase a copy of the videos to take along with you. I also have a Twitter and YouTube feed you can follow at professormesser.com/Twitter and professormesser.com/YouTube. I am watching the chat on the professormesser.com site. So if you go to professormesser.com/live, you'll be able to see that at the bottom. There is a chat that's on the YouTube side. I don't have that one up and running. So if you are watching this live, make sure you join the chat on professormesser.com. Well, I mentioned we do this every month, so I have a number of questions that we talked about last month. Some of the questions were, what's the differences between Radius and TACACS Plus? We talked about authentication methods and what those are about. One of the questions came in that said, which is faster, a Cat 5 or a Cat 6? We talked about wiring categories and why those are important and what you need to know for your Network Plus certification. How would you know if a gateway or DHCP is not configured properly? We're going to talk a little bit about DHCP this month on a different kind of topic, and we'll sort of add on to the things that we discussed last month. Will certifications alone actually get your foot in the door? Are the exams timed, and how much time do they give you? And how long does it take to complete a Network Plus after you've already taken an A+? So if any of these questions interest you, we won't be talking about any of them this month. You can go watch the one from last month. I don't duplicate information as we go from month to month, but there's always an archive that you can go to. Well, of course, I'd like to also ask questions of you. So if you have a QR code reader on your mobile device that you've downloaded, you've had it as an app that's been sitting on your phone and you've never used it, now's an opportunity to take advantage of this, because throughout the study group, I will be asking questions of you. Some will be pop quiz questions to test how much you know about a particular topic. But one of the questions I'd like to start with is, how long have you been studying for your Network Plus certification? If you go to vot.rs, you don't have to have a QR code reader. You can just pop open a new window or simply go to the browser that's in your mobile device and go to vot.rs. And it will ask you for a number. That number is 72684. 72684 is the magic number. And when you get to that site, you'll be able to vote on whether you've been studying for less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, and over 1 year. And when you get there and start voting on those things, we will start to see them on the screen here. So this is a nice way for you to give me instant feedback about what's going on. As we're waiting for those to come in, I do have a couple of calls holding, so I'm going to go to that 704 area code. Are you there, caller? Let's see if that one happens to be there. Are you there, caller? Can't hear anything. This is the beauty of being a one-man show, is I get to also do all of my own call screening, which is great too. Let's try the other one that I have here, which I think is actually from the same number, maybe called in twice, and I hear myself on that one. Are you there, caller?
Hello.
Hey, hello. Now we can hear you.
Yeah, I'm hearing you. I'm calling from 704.
Yes, you are. Welcome. And what's your name? What's your question?
My name is Joseph Benedict Miambe.
Thanks for joining us.
Yeah, thank you. I need to know because I'm trying to set up my computer. Do I need to monitor? Do I need to hear you from the computer or from the phone?
And that's you're trying to. Which part specifically are you working on?
I'm trying to set up my computer. I'm only hearing you from the phone. I'm not hearing you from the computer.
Right.
Do I need to hear from both the phone and the computer?
And that's one of the things for us in this particular study group. If you go to professormesser.com/live, you will be able to hear it. And it's a YouTube stream. So one of the things that I do on this stream is to do it on YouTube. So if you can watch a YouTube video, then you can absolutely watch what we're doing on this as well. The challenge I found, and we had a couple in the chat room already today, the challenge with Flash or being able to hear, you can watch a YouTube video, you can watch what we do here. So that part works pretty well, I think. And I've been looking at other streaming solutions out there. There's some good options available. We may not always do YouTube. I may do something else, but I think it's working pretty well for us. If we look at the questions that came in for the Network Plus certification, how long we've been studying, most of you on here have been studying for less than 3 months. You've got a nice mix, though. Some of you are more like me, where you've been studying for well over a year, trying to find the right amount of time. And as we go through the topics today, I have some topics that are introductory topics to the Network Plus, and others that we're going to dive a little bit more into the details. That might help for those of you that have been studying for more than a year. And I think those are the ones that most of us are going to be able to work on and be able to work with. If we go and look at this Network Plus certification itself, you'll notice it's one that's been out really not that long. 2011 was the latest version of this that was released. And so it has been out for a couple of years total. CompTIA tends to refresh their certifications about every 3 years. So this is really the most current and will be the most current Network Plus certification for at least the next year or so. And even then, there will be some overlap time. So if you're studying for your Network Plus right now and you're studying for the N10005, you are studying for the latest one, and nobody's going to pull the rug out from underneath you. You will have that certification available for a good time to come. The idea of this latest version has been adding some of the newer capabilities. Networking doesn't change a lot as we go from version to version. Even if CompTIA came out with a new version of the Network Plus certification today, that new version wouldn't be very different than the old, because Ethernet doesn't change a lot. There's faster Ethernet that you might have to learn, but the basic foundations and structures and spanning tree and understanding the cabling types and knowing the interface connectors, those are all the same. Those don't really change that much. Makes it very easy when you have to move from test to test, or when you have to change the content from test to test. If you are looking at taking your Network Plus certification, I'll also let you know that I have a PDF available that you can use as a final study guide. So this is something that we've added recently on the Professor Messer website. I'll try to bring it up on my screen so you can kind of see what some of this is like. Here is, let's see. I'm going to try to make it so you can see it a little better on your screen. There we go. So here's the PDF that I have. I've taken all of the visuals and the content and the information from my videos, and I put them into this study guide. It's a way that hopefully you'll be able to grab that study guide information, the information from my videos, and be able to learn a bit more about the Network Plus certification. Have a quick reference guide when you're ready to take that exam. I've got it for sale on the website for $10. And what's nice about this is every dollar from that goes right back into supporting our hosting on the website. We have so many people hitting the website. We have multiple servers now. There's load balancers. There's reverse proxies. There's a lot of networking that goes into keeping the Network Plus videos running. Our hosting is now just a little bit over $1,000 a month. So all of that really goes towards helping out the website. And for those of you, I released this last month, and it's really been overwhelming, the number of you that are helping to support, and I really do appreciate it. It really does go a long way to keeping things running on the Professor Messer website. We have quite a number of topics to go through this month. I don't even know if I'm going to have time to do all of the topics, but we're going to give it a shot. I'm going to to go through some of these. We got so many good ones. And a lot of the content this month is content that we have not done before. I created some new slides and some new content to help drive home some of these topics on the Network Plus certification. So with that now in place, let's now find, I have another question for you. Now, the key is, of course, with these questions that there is no answering of the questions in the chat room. So that's my one rule for you. When you're working with the chat room is do not answer the questions as they are coming through. So if we look at these questions, the question I have for you is, which of these, and I've listed these on the website on the voting that we'll do, which of these, and specifically got some protocols there, would you associate with the transport layer? I kept that very generic, the transport layer. Your options are Ethernet, MAC, HTTP, TCP, and IP. If you go to vot.rs and go to 959971, you can answer this question. Which of these would you associate with the transport layer? This is going to be pretty useful for the next topic that we are going to discuss. Remember, no answering in the chat room. You can also grab your QR code reader, take a snapshot of that, and go right there to find out which one of these would you answer. And let's see what those might be. Which of these would you associate with the transport layer? I'll put the QR code up and we can see the names at the same time. Oh, I should also hide the results. So we're going to see the result once everybody has those in. The QR code reader there. The options, again, Ethernet, MAC, HTTP, TCP, and IP. So those of you that have taken this Network Plus certification before, or you're on the networking side, you know this is something that really helps when you're trying to troubleshoot problems on the network, is knowing about the transport side of things and being able to communicate with someone over the phone. I'm having a problem with the transport layer because, and there's a number of reasons associated with that, some of which we will indeed discuss when we get into the other side of this. I think that's one of the ways when we start talking about the Network Plus certification. A lot of people get wrapped up in the idea that I have to know these layers. I have to be able to work with all of these different ideas of theoretical networking. But in reality, we use these terms, the transport layer, the application layer, the physical layer. We use them all the time in networking, especially when we're communicating with others and trying to describe some of the things that we are doing. And in the chat room, some folks were even talking about certification and recertification, and sometimes renewal. We're going to talk about recertification and renewal later on in the study group. Well, we have 30 responses here, so let's now show the results of what we have here. Which of these would we associate with the transport layer? 27 of you said TCP. I clearly have not fooled anybody with that one. 3 of you said IP, 1 said Ethernet, MAC. So obviously, if we had to phone a friend, I think we'd have a pretty good chance of getting the correct answer, which is TCP. Now let's start to blend these together. Let's start to try to understand more about the transport layer, what it means and how it fits with everything else. And this came to mind because the question that came in this month was, what are the differences between segments, packets, and frames? These become increasingly important to know, especially for certification exams, but it's also good to know to get your mind in the right place to understand, how does this work? How do all of these things interoperate together? So I want to step you through an idea of how the network actually works, and then we're going to apply those things back to segments, packets, and frames. So I put together an idea of us wanting to transfer data through the network. So let's say that we have an image, and we've got this image, and we want to get the image from one side of the network to the other. Let's say I visit a web page. If I visit ProfessorMesser.com, suddenly you get a screen filled with information. There's icons, there's text, there's messages on the side, there's search bars, there's all kinds of things that pop up on the screen. Well, it just didn't take the page, take a copy of that, and just suddenly send it all at one time down to your computer, and it's there. And you'll notice the page builds. There's different things on the page that build at different times, which means that things are coming across. And things like images, you can't just send across in a single time. They have to be cut up into pieces and sent a little bit at a time through the network. So the first thing that's going to happen is that my web server on my side is going to see that you're requesting to download an image that will eventually be created and put on the page so you can see everything on my website. So the first thing it realizes is, wow, this is a big image. I can't just send it in one packet. I'm going to cut it up into smaller pieces. And that's done by the web server. The web server, the application itself, is in charge of determining how much it can really send. But then it needs to somehow get it onto the network. My web server doesn't handle networking. So the first thing that it does is it sends it down to TCP, and it says, this is web server, so this is TCP. It's over port 80. Those are the things that we learn with our Network Plus certification. Please take and send this off to the other side. I'll just send you, here's a little piece of it, and TCP takes that little piece of it and breaks it apart and takes that one piece and puts a header in front of it that says this is TCP port 80 information, and it's part of the information. TCP is responsible for not only sending it across with that port number, but also determining which numbers of these packets make it through to the other side. We talked about TCP a lot in previous study groups and on my videos, and we talk about TCP as being one that is always doing this check of, did the data get to the other side? It's not like UDP where we just send the traffic through. TCP is one where we're setting up a connection and we're confirming and acknowledging the data got there. So there's a lot that happens in that header. I'm keeping these pictures very generic. This is a segment of data. So when we talk about a segment of information going across the network, that's a segment. Now, of course, there's no IP addresses in here. This is TCP port 80 information. It's a port 80 segment of TCP data. But I need to get it to an IP address that's over on the other side of the internet. So TCP simply goes down one level in the stack, down to the packet level, and says, please put some IP addresses on this. It puts its source address and it puts a destination address along with all of that TCP data. So we're adding more information onto that piece of the image that we are sending. This is a packet. It's an IP packet. This information that we're sending across has now source IP addresses, destination IP addresses, and header information, the TCP information that we're sending. So this is a process in the networking world called encapsulation. We are encapsulating the data within multiple layers of information. Yeah, it seems like it's very inefficient, doesn't it? It seems like it takes a lot just to get it across there. And the chat room's kind of going, is there a lot of overhead associated with that? And in some ways there is. If we're sending 1 byte across the network, there's a lot of data stuck onto that 1 byte just to get it to the other side of the internet. And we're not even done yet. The other side of the internet. That's why when people talk about sending large data, they talk about doing backups over the network. They talk about sending large images over the network. They talk about having large frame sizes and maximizing the maximum transmission unit, the MTU, or using jumbo frames, which are really large Ethernet frames, because the larger the frame, the more data you'd be able to send across at one time. So let's get down into the details of this. Now that we have an IP address, our Ethernet network doesn't know what to do with this unless there are MAC addresses involved. So we add another layer to the bottom, and that additional layer is the frame. This is where, when you start breaking apart all of these little pieces, this has to happen every time we want to send data across the network. We encapsulate it in TCP or UDP, that layer up at that section of the stack. Then we into a segment, then we have a packet with IP, and then finally a frame is the final piece of information that sits onto the Ethernet cable, the fiber or the wireless connection, and goes across the network. And on the other side, that frame is going to be broken apart multiple times till it finally gets to the other side, at which point the IP address information is pulled off so that we have the segment, the TCP information is ripped off of that, and finally we've got the data on the other side. So this is something that happens every time we send data back and forth. And if you start looking at the models that we have to learn for the Network Plus certification, that becomes pretty easy. We have this IP protocol suite that now is pretty useful to be able to do the piece of this. So if we look at each one of these layers that we have here, we've got application, where we're actually sending that image or that information, the search box, the text, the messages, that home page, that piece of information that the application starts. Then we have the transport layer, that TCP data that we wrapped around it. Then we put IP addresses at the internet layer around it so that the IP address information would go back and forth. And if we reference that back again, now we've got segment, packet, and finally the link, which is the frame that goes across the network. So at each one of these points, we now have taken models that we have discussed in videos as sort of a high layer overview perspective of theoretically this is how a network works, and it actually works exactly like that. It's not really that theoretical, is it? It really focuses right down to the way we operate and information goes back and forth over the network. Now, if you wanted a deeper view into this, I would recommend you grab something like Wireshark, capture some packets, start breaking out the packets. You will see the MAC address information, the IP address information, the TCP or UDP information, and the application data all within the packets that are going back and forth. So that's one very good way to go through and learn more about how to make all of this work together. I think it's a very good way to not only theoretically understand the TCP/IP protocol suite, but really put it into practice with segments, packets, and frames. Let's now shift our gears a little bit. I have another question for you. One of the questions that I have for you, remember, no answering in the chat room. We're going to stay on the networking side with getting data across the network, because the question that I have for you deals with routing protocols. And the question I have is, which of these would be considered an EGP? So now you have to know what an EGP is, and you also have to know the answers that I have available on my list. The answers that are available to you are BGP, OSPF, RIP v2, and EIGRP. So we have to know all those names, all of those acronyms, and being able to work with that. I think there's a nice blending together of these protocols, and for your Network Plus certification, it's going to be really useful for you to know what those protocols are. As you're answering that question, I'll remind you, we do have a call-in line. You can call 347-989-8745. And if you are on Skype, you can Skype for free at 855-235-4742. So feel free. I've also got those numbers on professormesser.com/live, and you can call in there as well. So our question about EGP and what it is and how it works and all of these acronyms becomes really important when you start setting up a network. And we're talking about multiple sites of a network. We're talking about being able to send data from one location to another. We're routing. There are routers involved to be able to make this happen. Sometimes we're routing within a campus. Sometimes it's between buildings. Sometimes it's across the city. Sometimes it's across the country, or it's across the world. This is an important consideration if you're setting up your internet connection, if you are configuring routes to a separate location through a VPN, if you are setting up multiple connections out through your environment out somewhere else, it becomes really important. So our question, which of these would be considered an EGP? Now we have to know a lot of these acronyms. So you should be going through these acronyms and knowing that I know that one, I know that one, I know that one, I know that one. Each one of these is important to know for your Network Plus certification. So we've got about 20 responses. Let's see what our answers might be across the board. Well, now I finally hit a question where we really had to think about this one. Our answers, 9 of you said BGP, 4 of you said OSPF, 4 of you said RIP v2, 5 of you said EIGRP. Now, let's first break down what this answer is. I'm not going to give you the answer right away. So let's really discuss what this is. The reason I got this question is that Ken sent this in and said, could you go over the concepts of RIP v2, BGP, EIGRP, and OSPF? Ken obviously working on his Network Plus certification, because you have to know all of those to be able to take your certification exam. You may be asked questions about these routing protocols and how they operate. Let's talk about the differences between an EGP and an IGP. And let's start with IGP. IGP is I for interior, E for exterior. And these are interior gateway protocols. These are routing protocols that are generally used on the inside of an organization. You're not really communicating to a separate organization, a separate facility, a separate group of people. Usually these are all within our own set of management. So for things like these, what we call autonomous systems, are these groupings that are within our own responsibility. So we're setting up a bunch of routers. We're part of an organization. Let's say we're part of an insurance company, and we've got locations in Orlando and Tampa and Tallahassee and Miami, and we've got all of these in the state of Florida. I'll set up routers in each one of those locations. I'll contract with a wide area network provider and say, please give me a link between all of those. Now I have to route traffic. How do I route it? I route it using, because this is all within my autonomous system, I'll route it using one of these IGPs. So the IGPs that are used internally are OSPF, ISIS. That's one you don't often see in an insurance company, but for those of you that are service providers, you may see that. RIP for Routing Information Protocol. RIP v2, there are some differences between those two. EIGRP. And so if you're setting up these routers and you're sending traffic from one place to another, these are some of the things that you will be using. You may just choose one of them to use in your environment. If you're a very large Cisco environment, you just may use EIGRP to send dynamic routing information between all of these routers so that they can send information back and forth. You may use none of these. You may decide that I don't want the routers making their own determinations of how to route. I'm going to statically route them. There's a lot more management involved. You have to go to every router and tell that router where to send traffic, which is you got a very simple network that may be a good solution for you. But when you have multiple locations and you have a meshed network and you have multiple ways to get to different sites, these dynamic routing protocols can be really, really useful for you. OSPF is probably the next more popular, one of the most popular routing protocols to use internally within an organization because it's supported across multiple routing, multiple devices, a very open standard that's been around for a long time. Now, if that's the interior routing protocol, in fact, the question I asked you was about EGP. Which one of these things would be considered an EGP? And EGP is when we are talking out to another organization. We are talking to a service provider. Maybe we have a business relationship with a third party and we need to send information between those locations. We might use some type of exterior gateway protocol to make that happen. So the type that, and here's the answer to the question that I asked you earlier about what would be considered an EGP, BGP, which is the Border Gateway Protocol, probably the number one EGP that you'll run into. If you're connecting to a wide area network service provider that's giving you internet access, especially if you have multiple internet access connections, you're probably using BGP to make that happen. Most people will use something like static routing. They won't use a dynamic routing protocol, but the BGP and the dynamic routing protocol capabilities provide you a number of advantages, especially when you have multiple connections out to the internet. So if we look back at the question that was asked earlier, which of these would be considered an EGP? The 14 of you that said BGP were absolutely correct. If we were going to look at a picture of what this might look like, this is what you might see on someone's network. So here's one company, they're running RIP inside their organization. Company C, they're running EIGRP, another running OSPF, another running RIP v2. Some organizations will run multiple interior gateway protocols. It gets pretty complex when you start doing things like that, but there might be good reasons to do that, along with doing a bit of static routing within that. But if you ever have to talk out to a third party, if you have to go between companies, that's where the BGP is going to fit in for you. That's where you're doing that exterior gateway protocol and being able to route between those. Now, this is a pretty simple configuration, and these companies are routing amongst each other with the BGP, but I wanted to give you one more example. This is one that's not in my videos, but I just went to one of the tools that I use that I play around with when I want to do some routing and some switching and build things out, and I took something from a lab with one of those just to give you an idea. Here's an example very similar to the one I was just describing. Let's say you have an organization and you have just in Florida an office in Orlando, Daytona, Tampa, and Miami. And of course, you've got these other hosts out to the side with all of those pieces. There's even a Key West down here. Notice that Miami has a single link to Key West, but all of the other sites, Orlando, Tampa, Miami, and Daytona, have multiple connections. So if I wanted to get from Orlando and get down to Miami, I could go through Tampa or I could go through Daytona. So you've got different options here and different ways to do this. Now, the real challenge, of course, is if you lose one of these connections, you want to be sure all of your data flows the right way. This is a great opportunity to use a dynamic routing protocol like OSPF, like EIGRP, like RIPv2, where you turn that on all of those routers. You configure them to use those routing protocols. They go out and figure out themselves dynamically what other routers might be out there, and they all talk to each other and say, okay, I know you're here. I know you're over there. I know to get to Miami, I can go this way or that way. I'm going to take that one by default. There's a number of algorithms that these protocols use to determine what the best route might be. And the beauty is if anything changes, a thunderstorm comes through and takes out the link between Orlando and Tampa, the routing protocol recognizes that a change has occurred, and now it goes and changes its routing function to route around the problem automatically, dynamically. You don't even have to log into the router. You don't have to make any configuration changes because you've set up these dynamic routing protocols to make that happen. Now, the process of figuring out those connections between those, that really is the key. That's when you get into your next level of certifications, would probably go into more about how does OSPF do that? How does BGP go through that process? How does EIGRP know which route is really the best? You don't have to know that level of detail for your Network Plus. All you have to know is that these are the routing protocols that are used, some of the advantages and disadvantages between them, and this is exactly the scenario you might run into if you wanted to use some of those routing protocols. Well, let's go to this month's algorithm. I've got a number of things to go through. I talked earlier, we may be talking about some interesting topics, and I get all of these together from what you send me every month. The question that came in from and obviously with Network Plus, tons of algorithms or tons of different acronyms to deal with. And so for this month's acronym, I have a question of what is APIPA? And there's your QR code reader. Do not answer in the chat room. The answers, the potential answers I have for you is APIPA. Is it a routing protocol? Is it a way to assign IP addresses? Is it a troubleshooting utility? Or is it a network operating system? And you can find that by going to VOT.RS and answering 223036. I'll also take this opportunity to let you know you can call in and ask a question yourself at 347-989-8745, or you can do this free over Skype at 855-235-4742. The country code in each one of those is a +1. So we go back to the APIPA, and if we look at APIPA, is it a routing protocol, a way to assign IP addresses? Let me hide the results here before anybody answers. A troubleshooting utility or a network operating system. This is something you will run into specifically when working on the side of networking. You will run into APIPA quite a bit, so it's very useful to know. And as we go through this, I'm not only going to describe to you what it is, but I've got some additional content that you won't get from the Network Plus videos. So this might help you understand more about APIPA and the processes behind it. There's a little hint for you. We've got about 20 responses, so I'm going to go ahead and open up the answers that we have. 22, 24. Okay, let's show the results. And 20 of you, didn't fool you on this one, said it's a way to assign IP addresses. And it is indeed a way to assign IP addresses. This question came in from David, and he asked, what's APIPA used for and when is it used? Which is probably a more interesting question for us doing Network Plus. The automatic private IP addressing is what the APIPA stands for. This is a way that you are able to communicate on a local network with other devices, even if you have not configured an IP address and there is no DHCP server. So normally, back in the day, before automatic IP addressing, if you did not configure a IP address on your device and you did not have a DHCP server, you simply did not get an IP address. You couldn't communicate. Well, that doesn't help very much. It would be nice if you could simply plug your computer into a network and it would at least be able to communicate with other devices on that local network. And you can do that through APIPA. It's automatically assigned. And if you wanted to see the API, if APIPA was configured on your device, you simply look at the IP address. The automatic IP address ranges that would be made available on your machine are from 169.254 1.0 through 169.254 254.255. This is whenever we're plugging into a network and we've connected to it and we pull up our computer and we look at our IP address. If you're a network person and you see anything that starts with 169.254, you oh no, I didn't get an IP address from a DHCP server. What's wrong? Why did I not get a DHCP address? So this is very useful for being able to use this. If you look at the IP address configuration, there's a good example. You'll see it. The address right here, 169.254. Oh, I've got an IP address that is an automatically assigned IP address. Now, how does this happen? How does this process work to get an IP address automatically? Well, your computer goes through a number of steps to make this happen. So the first thing, of course, you plug in. It'd be great if there was a DHCP server there. If there was a static IP address, obviously, we're not doing any addressing automatically. We simply have an IP address and we go on about our business. But if there's an automatic DHCP configuration set, the first thing our machine is going to do is to look for that DHCP server. Where is it? Where is it? Where is it? Now, we're going to keep trying a number of times to see if we can get a response from the DHCP server. If we don't, your computer realizes I need to set an APIPA address. I'm going to pick a random number. I'm going to go through my range, the 169.254, and it's not going to be sequential. It's going to be random. I'm just going to pick a number in that list to use. Now, the real question is, how does your computer know that it didn't just accidentally, through the luck of the draw, happen to pick something that someone else has already obtained? And it does that by taking advantage of the ARP protocol. The ARP protocol obviously is one where you can send out a request saying what MAC address is associated with a certain IP address, and that IP address will return the MAC address. This is also a good way to discover who might be on the network. So when I pick a random number, I send an ARP that says, hey, whoever has this random number, this random IP address I just created, if you're out there, send me your MAC address. Now, if I get a response back, then somebody else already has that IP. If I don't get a response, maybe I send a couple of ARPs, didn't hear back from anybody, that IP address, therefore, must be available on this network. I know there's no conflict, and I will use that IP address. If I do have a conflict, I just go through the process of keep asking. I just pick another random number, and I ask again to see if I ever get a response. And finally, I will run into one of these numbers where I'm not duplicating somebody who is already out there. Now, in the chat room, somebody made the comment that I thought the range was 169.254 0.0 through 169.254 255 255, and it is not. The very first set and the last set of 256 addresses is reserved. So we start the ranges at 1.0 and end at 254.255. It looks funny on the screen, doesn't it? That's not the case. It actually does have those reserved ranges at the very beginning and reserved ranges at the very end. Now, even though we get an APIPA address, we're still not done. By default in Windows, every 5 minutes, it will keep checking in to see if the DHCP server ever came back. So we'll send the DHCP broadcast to try to find the discover message, to try to find that particular device out there. And if it finds a DHCP server at that point, oh, the DHCP server's back. Let me grab an IP address from that device, and I'll start communicating on the network. Now, one of the things that in the chat room, some of you even realize you're thinking about this one is, now wait, these are just IP addresses. There's no gateway here. And you're absolutely correct. If you get an APIPA address, it's a link local address. It is an address that's designed to work on the local subnet. You cannot communicate out to other subnets using these APIPA addresses. So that becomes important consideration. You can talk to other devices. You can print to your local printer. You can share files as long as your file server is on this subnet. But if there is anything outside of this local network, you will not be able to communicate with that through an APIPA address. Wow, enough of the abbreviations, the APIPAs of the world. and getting those to happen. I also want to make you aware, some of you have sent questions in this month about the Network Plus certification and the performance-based questions. And some of these performance-based questions may indeed have requirements for you to perform a simulation. Now, performance-based questions may not necessarily be a simulation, but it's important to know that that you may get asked to perform a command line function down at just to give you a blank command line, and now I have to perform a trace route or a ping or any one of the commands that are required for the Network Plus certification. Now, this is great if you have multiple machines and you have devices that you have got configured in your environment. You've got your packet capture here. You've got a hub so you can capture those packets. You've got separate servers that you can use to transfer data. And you've got all these already set up in your lab. Not all of us are fortunate enough to have that configuration. That's why my friends at GTS Learning have made available to us the GTS Learning Live Labs. They have a nice opportunity for us to use a lab that's already virtualized in the cloud. It is a interactive, always available. Anytime I want to sit down and run through a lab, it's available to do that on the GTS Learning Live Labs. These freestyle labs are set up so that at any time, if I wanted to go through and pull up a lab, let's do a lab on this screen of configuring email services. So I haven't started this one before. So it sounds like a good one to use. I'm going to click on that one. And you'll notice there's even a network diagram set up of how this particular piece, this one has a server. I'm going to start that server up and power it on. I've got a client. I'd love to get my client running. There's a gateway that I can power on. There's a separate router. And then there is the Linux Apache PHP LAMP stack that I've got available to run. So all of these machines are now booting as if I went to each one of them and powered them on. Now, while we're going through that, they've already got labs and exercises set up for me to go through. Here's my lab and configuring it out. And the entire lab configuration is on the screen as well. I can pop this out and see it as a separate screen if I want to, but this gives you a feel for the configuring. They even give you screenshots. These are both on my screen at the same time, so I'm able to follow along and see, okay, and sure, I've got the required devices turned on, and you can see some of these things like the gateway is already starting up. I've got now my router is on there. Let's go back to my gateway configuration. There's my gateway. So I've already got a Windows machine already running right here, and I can make changes to this gateway. I can make modifications to this. I can follow along with the gateway server settings that I have on this piece. This is one of the nice parts about this Live Labs is that it's always on and it's always available at any time. Another nice piece of this is that you can try it for free. They'll give you an hour that you can use to see, is this really something I should be using? You can go ahead and connect to these. I can pull up one of these server configurations. Look how easy this is to work with just a HTML5. I don't even need extra software to make this happen. I can follow along with the information I have here running PuTTY and the other pieces on this machine. It's all available, and all these labs from the exercises for each step of the way are available for me to use all on here. Look, I've already got 3 machines up and running on this. So now I'm able to start working with Wireshark. They've got IMAP already loaded. PuTTY is already loaded on here for doing SSH. And there's an extra nice piece of this is GTS Learning set a nice price for us here at Professor Messer. If you want to try it yourself, you use it for an hour and you realize I need this to do my Network Plus certification, you can go out and purchase it for just $99. That gives you a 12-month subscription. So for an entire year, you will have access to all of these labs to do whatever you'd like, whether it's during your Network Plus or even afterwards, if you have things you would like to do as well. So I just want to make you aware of that. Our friends at GTS Learning have been nice enough to support what we do here at Professor Messer. And if you have a need to be able to have labs available and work with that, you can take advantage of that as well. You can see those, try them out at professormesser.com/netlabs. So there is a question that came in from James. What a good name that James has. And his question was, I have multiple NICs on my system. How does Windows or Linux determine which interface to send data? We were talking a little bit about this earlier. We talked about routers, and we had set up routers between Miami and Daytona and Tampa, and we had Key West. We had all these routers. And when data comes into a router, how does it know which way to go? Now, the mechanism for building the routing table itself were those protocols we talked about. It uses OSPF, it uses RIP v2, it uses EIGRP, it uses all of these methods that might be available, may just use one of them, to build a routing table within the router. We also have routing tables within our devices as well. The routing tables within our devices work exactly the same way as the routing tables that are on a router. Same type of functionality to make that happen. So if you were to look at, for instance, the routing tables on your device, you've got on your workstation, if we were to look at those, you'd have a list of all the routes available to this device and where it should send the data. Now, I have a Windows machine right here that we can look at that has 3 interface cards inside of it. It's going to bring up a command prompt for us to look at. This command prompt is going to bring up a lot of data. Be good if make this nice and long so we can see this, and I'll zoom up so we can see it a little better. I'm going to use the Windows command route print -4 because I have IPv6 on here. There's all kinds of protocols running on here. On this computer, I have 3 interfaces, interface 15, 14, and 10. There's the MAC addresses. And I just set up 3 adapters. I'm running this in VirtualBox. So all I did was I wanted more adapter cards. I just added some to the virtual machine. It was that simple. I love virtual machines. It makes it so easy to play around with this because I wanted to show you a routing table, and I wanted it to have multiple connections to multiple locations. Now, each one of these is configured. One is configured to bridge onto my local network. One is configured to NAT onto my local network, and one's configured to be an internal-only network that does not route anywhere. So when I look at my routing table and I start breaking this down, here is how my computer determines where traffic goes. So let me make this so you can see it a little bit better. Let's start at the very top of this. So if we go to, I see that I have some default routes, which are whenever there's not one already listed in my routing table here, send it out these locations. In fact, I have 2 default routes, 0.0.0.0 with a net mask of 0.0.0.0 means these are the default routes. So I have 2 on mine because I have 2 connections. And in Windows, the default routes are added to your routing table in the order at which the adapters are bound. So the first one that happened to be loaded in Windows was the one that points to gateway 10.1.10.1, which is my bridged connection on this network. And it goes out a local interface of 10.1.10.59. So if it's not any one of these other connections, which is 10.0.3.0 with this subnet mask of 255.255.255.0, or I've got some other local networks on here. There's 169.254 because I did not have a DHCP server on that internal only network. So I got some APIPA addresses on here of 159. So if you need to stay local on, if I was communicating to something that started with 169.254 and communicated out on that network, then it would go out that particular local interface. It wouldn't go out to the internet. It's local. My routing table already knows anything that's 169.254, stay local and go out this particular interface. Now, if I needed to go out to anything that's a 10.0 network, I've got a 10.0.3 network here. If I need to go out there, I will then see, oh, my destination 10.0.3.0 goes out interface 10.0.3.15. So all we do is look through this routing table to determine what the best route is going to be. And if we're trying to follow the steps and troubleshoot as we go from one machine to another and step through the entire process, we use these routing tables to be able to make that happen. Yeah, this is a pretty, everybody in the chat room's like, where? That's a big routing table there. Well, I intentionally made it big because I just started adding on multiple interfaces. And if you look at these large enterprise routers that you're going to use when you get into those roles, you might have a router that has 10 connections going into it. It may be a relatively complex and very large routing table, but don't be thrown at the size. This is just an index. It's a map of where to go. The packet comes in, and unlike me, it actually asks for directions. The packet comes into the router and says, hi, how are you? I'm trying to get to Google. I need to go to 8.8.8.8. Well, that's good to know. Let's go back to our routing table. Let's see a packet came into this machine, and it needed to go to the Google routing table. And if I look at this, I go through this entire routing table, the 8.8.8 network is not specifically listed anywhere in here, which means it falls over to the default routes, which means it's going to use the first default route in my list. The gateway is 10.1.10.1. The interface is 10.1.10.59. So if I need to send a DNS query to 8.8.8.8, it's going to go out my interface, the card, the adapter card in my computer that has the IP address of 10.1.10.59. And it's going to, because it's outside the subnet, going to be heading toward my default router, which is 10.1.10.1. That's it. Packet comes in, figures out where it goes somewhere else. That happens for every packet that comes in. It looks at the destination IP address, looks through its table of where things go. It finds the one that matches the closest to that and sends it out that connection. That's it. Now, I say that's it. Whenever I am configuring a router for the very first time, you not only have to configure routes in the router either statically or through dynamic routing protocols, you not only have to configure it going that direction, it has to be configured coming the other direction as well. Otherwise, you're going to send data out to Google, and Google will come through and it gets to your ISP, and the ISP says, I have no idea how to get back. Nobody told the ISP that I set up this router. And in those cases, the packet gets dropped. So there have been scenarios very often where I will configure a device, they will give me routing information, we will send the traffic out and get no response. And that's why you have to have routes that work in both directions. The routes don't magically work both ways because you set it up on one side. It has to work from the other side as well. So an important consideration about using those and how they work. Now, if we look at how routes are working in the network and how we would work with them, these routing tables become really, really useful to know. So the details of how the routes get in there, as I mentioned before, a little bit outside the scope of your Network Plus certification. But if you are in a position where you will be managing routers, or you just would like to manipulate your router configuration in Windows, you could tell Windows, you can add routes to this at the command line. You can delete routes from this at the command line. So if you have both a wired and a wireless connection, you could delete your default route on the wired side and tell everything to go out the wireless, or vice versa. There's a lot of control that you have with these pieces. So feel free to take advantage of some of those. You may even want to play around with them. Again, they're outside the scope of the Network Plus certification, but you can really, really be able to work with this and do some interesting things with it. One of the questions that come in every month deals specifically with questions about the exam itself. So it may be useful to take a few minutes and talk about some of these questions that came in. Here's a question that happens quite a bit. With the Network Plus, I get fewer of these all the time, but the question that came in was from Aaron that said, I have books for the N10004 exam. Now, obviously, the only Network Plus exam you can take these days is an N10005 version. That's the latest. But if you have books for the N10004, can I use those? Is that something that might be useful? Obviously, the best possible book is going to be one, our best possible materials of any kind will be those that have the newest, or at least the version of the exam that you plan to take. In this case, it is the newest. It's the only one available, which is the N10005. But as I described before, there are very few differences between. There's probably 85 to 90% overlap with the Network Plus certification. There was some virtualization information was added, I think some additional IPv6. I'm trying to think back of all of the things that happened, but there have been changes. And some things were dropped from the exam. Some of the older topologies that you won't run into anymore are no longer in the Network Plus. It's updated every 3 years. You're always going to have the latest information available. So if you are going to be working towards getting your Network Plus, I would really encourage you to get materials that have been written for the latest version. But we are not in a position to go out and just buy new books whenever we can. So if at a very minimum, you might want to look at an N10004 objectives, look at the 005, compare the two, see where the differences are in any place where you're missing data from your book. Go out to the internet, go out to third parties, watch my videos that deal with those particular topics so that you will at least be familiar with those. Pretty useful when you're working along those lines. Sean sent a similar question since we're talking about exam objectives. His question was, what port numbers are going to show up on the exam? And we're always worried about port numbers. We're worried about topology types, interface configurations, because all of those are things that we really have to memorize. If you've never worked with them before, then you are going through the process of needing to memorize all of those things when you start working with them. So in those scenarios, I highly recommend that you go right to the certification guide. If you go out to the CompTIA website, the Network Plus section has right on the front, download the objectives, and you should. And you'll get the objectives, and you'll be able to read through exactly what's expected of you. And if I wanted to know what ports are going to be on the exam that I need to know about, I could flip through. In fact, it tells me exactly. Identify common TCP and UDP default ports, section 1.5. Here they are. Now, it will tell you at the top of this exam objectives that we may ask things that aren't in this list. And they do that because they do want to give themselves an out. If they want to ask something that has not been specifically written here, they can. But what we have found is that they stay very, very close to the list of objectives that is in here. They aren't trying to fool anybody. They really do want to give you every possible thing that you'll need to know for the exam. So you've got the list. And in fact, you'll notice the list here is probably the most number of ports that you'll need to know for any of the CompTIA A+, Network Plus, Security Plus. Security Plus asks for a number of these, maybe a couple of extras, and it dropped a number, but it's a smaller list for the Security Plus. Network Plus, certainly the largest one. That's why on my study guide, right on the front, which pages, I list out all of those ports and what they do and how they operate. You'll have exactly what you need to know. I went through this entire document and found every single port, even the ones they don't ask about port numbers. They list out, for instance, that you need to know about. As you need to know about SIP, you need to know about RTP, you need to know about IMAP4. So I at least added those into the list as well. So once you have this objective page, you will have everything you need to know to pass that certification exam, everything you'll need to memorize anyway to be able to do that as well. There is also, this came up very early, and I mentioned we'll be talking about this, is how can I renew my Network Plus certification without taking the test? If I have to talk about renewals, this is a topic that comes up a lot. There is an important consideration for the CompTIA A+, Network Plus, Security Plus, and CASP, the higher end security exam from CompTIA, is that when you become certified, those certifications are good for 3 years. You can learn more about this on the CompTIA website at certification.comptia.org/staycertified.aspx, or just Google up CompTIA Continuing Education Program. You'll find all of the details for that. The key is that you have 3 years in which to renew this certification. Now, you have two options when you first get your exam. You could say that I'm not going to participate in this education program. I'm not going to participate in this renewing program. And at the end of 3 years, it's just going to expire. And at that time, if I need to take it, I'll take the entire exam again if I ever need to get that certification again. So this is a situation where maybe in 3 years, you don't need to have your Network Plus certification, or you're only getting it today for a particular reason and you don't care or need to have it 3 years from now. I don't think that's going to be the scenario for most people. I think most people are going to have this certification and they're going to want to maintain it. Now, that doesn't mean that in 3 years you have to take the exam again. Once you take the exam one time, you never have to take the exam again. You can keep renewing the exam without ever taking the exam again. That's an important consideration. People think that, I've got to take it again. You never have to take it again. You're done. You're finished taking your Network Plus as long as you participate in this continuing education program. Now, for things like the security or the Network Plus, the continuing education program also assumes that you are doing things that are going to count towards continuing education units. So let's bring up that CompTIA website. And if you look at it, the continuing education program says that the certifications that we're looking at, like Network Plus, require that during that 3-year period, you accumulate 30 continuing education units. Now, you can do many different things to renew your certification. You can achieve a higher level certification. When you take, for instance, the Security Plus, it gives you a certain number of CEUs that are then applied towards this. So taking a higher level cert gives you exactly the CEUs you need to renew, and now you're good for another 3 years from the point where you renewed. You could also complete separate activities. This is a way that you could go through the process of a lot of different things. You can go to training classes. They have a list. Let me find this list. Where is it? Oh, qualifying activities. So here's the PDF. You can earn a non-CompTIA certification. You can go take a third-party cert and pass that one. They have a big list, and that gives you a certain number of CEUs. Notice that it gives you 30 CEUs, which is exactly what you need. You could, let's scroll down a bit, complete a training course. If you're completing a Security Plus training course, that gives you plenty of CEUs. Maybe you're watching this live. You're watching this particular presentation, and if you were to send me an email that had the keyword renew in it, then I would send you a message that says, I certify that you have watched this, and that would give you a certain number of CEUs. In fact, let's scroll down and find it. Attend a live webinar. I think that qualifies as what we are doing. You get 1 CEU per hour for the live webinar. And for Network Plus, you can earn a maximum of 6 CEUs during that 3-year cycle. So you could watch 6 of my live study groups. You could send me the keywords that I ask for during that study group, or send me a list of all the questions that are on the slides during that study group. And I will certify, I'll send you a note back that certifies that, yes, you took this study group, and it would count for 1 CEU if you provided that to CompTIA. You can get up to 6 of those. So you can't watch 30 study groups and have what you need. You can only watch 6. You have to use some of these other activities to be able to do that. I think most people will simply take another certification. They'll take a higher level cert, which then will renew the lower level certs. I think that's the easy part. And in the chat room, that's what you're already mentioning. If you take the Network Plus, it renews the A+. If you take the Security Plus, it renews both the Network Plus and the A+. So the higher level cert will renew all the lower level certs at exactly the same time. You don't have to accumulate 30 plus 20 plus whatever it happens to be. Just renew the highest level. It renews all the lower levels as well. Now, if there is a catch, here's the catch. You have to be part of the CEU program, which means that you have to give CompTIA the maintenance fees associated with the CE program. So for Network Plus, you need those 30 CEUs. The annual fee for this is $49, which means for the total of 3 years, you have to give $147 if you plan on renewing. So that's really the question that most people have. That's their tipping point to be able to pay those CEUs. Yes, you have to pay the CEU fees if you're going to take a higher level exam, because when you take the higher level exam, you're accumulating CEUs. The only way you can use CEUs is if you're part of the CE program. And the only way to be part of the CE program is to pay the annual fee for the CE program. So just taking the higher level exam, if you just go out, you didn't send CompTIA any money. A year from now, you go out, you've already got your Network Plus. A year from now, you go out and you take your Security Plus, and then you show up to CompTIA and go, aha, I took my Security Plus. They say that doesn't renew your Network Plus. You weren't part of the CE program. So that's an important consideration to keep in mind, is you have to be part of the CE program to renew, period. You have to give them $49 a year if you're Network Plus to be able to renew your Network Plus certification. Bottom line. Otherwise, it doesn't renew. Or you wait 3 years, it automatically expires, and you would take the certification again, which is going to cost you, a good chunk of money as well. It's almost a wash between those two. So it's really up to what you want to do. If you'd like to avoid taking that certification exam, again, you pay the CE fee, you pay your annual fee for this, and you start accumulating those certifications. And it's just a little bit cheaper to join that program than to pay for the exam again. So there is a little bit of cost benefit to be able to make that happen. So if you want to know more about the continuing education program, you want to learn more about how that works, they have frequently asked questions, tons of documentation. It's all on the CompTIA website. You can learn all about the renewal process and how that works, and see exactly what exams I can take, what third-party exams I can take. All of that is on the CompTIA website. Plenty to be able to look at. Well, I have another question for you. This will be our final question of the day. Get your mobile devices ready. And this one probably is the one that's really most important for me. The question is, what would you like to cover next time? I've got an hour set aside in January that I need to fill, and you can help me fill it. So if you go to vot.rs and go to 826815, you can just type in all of those pieces to find out what you'd like to cover on the next study group. That's one of the things that that makes this easy for me, is that I simply just take your questions and I fill in the list and we go through those. We went through a lot today. In fact, some of the content set aside I wasn't able to get to in this hour that we had today. We'll be even covering more of that next month. So those pieces will be in there as well. You go to vot.rs and simply type in your question, 826815, to be able to answer those. There is a lot of content on the Network Plus certification, plenty of content to go through. And if you're trying to get through your cert and your certain topics really bother you or creating a problem for you, you can send me an email. There's a contact us link at the top of the Professor Messer website. Just click that. It sends me a message, shows up on my mobile device, shows up in my email front end, and I see immediately. And these all come to me. This is a crew of one. So nothing slips by me. Everything comes directly to me. My staff doesn't hide anything from me because I don't have any staff. It's very, very efficient. If you're looking for the most efficient way to get data from a customer to a company, that's a very good way to do it. We'll see how much longer we're able to do something like that. So the questions are coming in. Quite a few are coming in with those pieces. Some are dealing specifically with topics that we just weren't able to get to today. Let's pull up that list and see them. A lot of you got this word cloud that's going here. Routing and protocols, certainly number one. Wiring always tends to come up because with networking, we're so used to just plugging in the cable. You never have to think about it. Now we really do. Protocols and routing and protocols. I have the list that you're sending in to me that I get to see on my side. So I'll see your exact questions. If one's very important to you or you just like more time to explain what you're looking for, feel free to send me a message there. You can, of course, send me notes on Facebook, send me messages on Twitter as well. I look for all of those constantly up. I really need to get things like my Instagram going well. And if you ever need to go to Professor Messer and find me, go to professormesser.com/Google Plus /YouTube /Instagram /Twitter /YouTube they're all there. Just slash something. You'll find me. And if you slash and I'm not there, I probably don't have one of those. And you can send me a message and say, why aren't you on? Pick your favorite site. And I'll be glad to get to that. So lots that we can talk to next time. Quite a mix of some of the things that we have there. So I will absolutely go through that list of those so that we can find out more about what the things that you need to know about. So, until next time, I've got plenty of things that you can look at. Thanks so much for your support so far with our Network Plus study guide. This is helping to keep the lights on the website, and your response has been remarkable. And other people said, this is a really good guide. I can really make some use of this. You can find out more about it at professormesser.com/netsg, Network Study Guide. I also have, of course, all my YouTube videos on professormesser.com/YouTube. The Twitter has all of the information on Twitter, and I'm pretty good about responding back and forth to those. So if you have questions, I'll be glad to answer those. I always keep my Google Plus page up and running as well. Very useful for those to have those available. And of course, Facebook is there as well. I think probably the best possible communication mechanism on this one, Twitter and Google Plus are pretty good. Facebook, you never know exactly if you're going to see posts that I have there, but those two, you'll absolutely see those. Again, thanks for GTS Learning for making that special pricing available for their Network Plus labs. You can find out more at professormesser.com/netlabs. And of course, thanks, of course, to you and what you're doing there. I would never be able to get all of these individual questions sent out every month if I wasn't able to take this compilation that you're sending me and do something with it. So thanks for joining us this month. We'll see you next time and next year on the Professor Messer Network Plus Study Group.